Hello guys, welcome to Organic Embers YouTube channel. In this series of videos, I'm going to solve some of the interesting and difficult questions from the hydrocarbons chapter. And if you have any queries or if you want me to solve some questions, you can always drop the questions in the comment box. Now let's get started. Which of the following product is formed in the following reaction? Observe the reaction condition. Whenever you have a 5-membered cyclic molecule and an addendum like HBr water, remember it's mostly a ring expansion reaction. What do you mean by ring expansion? Say let's assume if there is a 5-membered cyclic molecule, it will open up and it will form a 6-membered ring molecule. This is called as ring expansion. And why it happens? Because by opening up the molecule and expanding the ring, the molecule will gain more stability because a 6-membered ring is more stable than a 5-membered ring. By now you might have guessed what will be the right answer. Yes, the right answer is option D. But how are we getting this product? So in order to understand this, you should know how to write the mechanism. Now, what is mechanism? Mechanism is stepwise explanation of a reaction. So let's get started. When we have an alkene, when it is added to HBr, the electrophile from the HBr, that is H plus, will be added to the alkene because alkenes are electron rich. Therefore, they will attack the electron deficit. So, which is electron deficit here? H plus. That's why we call it as an electrophile. Now, this H plus either can add to the carbon number 1 or it can add to carbon number 2. But it always goes to the carbon with more number of hydrogen. Why so? Because it is obeying Marconi-Kaw's rule. So when the hydrogen goes here, right, a carbon with more number of hydrogen, here we have 0 hydrogen, 1 hydrogen, so it goes to the carbon with more number of hydrogen. So there will be 2 hydrogens here. And what about here? Now since this carbon lost its pi electron to the proton, what happens here on this carbon? We are going to get a reaction intermediate, that is carbocation. The formed carbocation is a tertiary carbocation and it is quite stable. That's the reason the hydrogen is added to the carbon number 1. Okay, now this carbocation, right, wants to be still more stable. That means what? If this ring opens up, how the ring will open up? So there will be first thing now it's going to happen is hydride shift. What is hydride shift? A shift of hydrogen from this carbon to this carbon. It always happens on the adjacent carbons. Okay, remember that. Why it is happening so? See, when the hydrogen as hydride, when it shifts here, this carbon is again becoming electron deficient. So again it will have positive charge. So again it is tertiary. From tertiary to tertiary, right? So that's okay. Tertiary to secondary or primary, we don't do it, alright? Now the carbocation is formed. Now the crucial step here is the ring will open up. You can either break from here or here. The bond you can take from either here or here, doesn't matter because it's a symmetrical molecule. So I would prefer taking from here. That means what? The ring is expanding. If you don't understand this in one step, I'll give you a simple trick how you can make it. If you don't understand this, you try to polarize the bond. What does that mean? So instead of attacking here, I will write it in 2 steps, okay? So it's actually 1 step, alright, but many students will not understand how it is happening. That's the reason I try to polarize this bond. So this is negative and this is positive. Remember students, most of the time it is 1 step. So now what is happening here? This bond will attack. Okay, so now look at this 1, 2, 3, 4, 5, 6. Yes, you formed a 6-membered ring like this. Now, when it attacks here, look at this. On the carbon, there are already 2 methyl. Write that as it is. And on this carbon, there are 2 methyl. That means the adjacent carbon will be positive. Like this. As I was telling you earlier, tertiary can become tertiary, but tertiary becoming secondary, not so stable, right? So again I have to form a tertiary. So for that what I do, I shift a methyl. Methyl shift. The hydride shift, methyl shifts are very common in a carbocation reaction mechanism. So the methyl will shift here. What happens here? The carbocation will be formed. From wherever the carbon bond it is broken and it is moving, that's where you have to write the carbocation, because now the carbon here is trivalent. That means there are only 3 bonds, right? It is deficit of electrons. So now what happens? Now comes the nucleophile, because ultimately you have to neutralize this, right? So now what happens? You have a methyl here. There is already methyl here. The bromine is attacking here. Therefore, the final product is as shown in option D, right? So, of course, you see that this and this molecule, they look different, but they are one are the same, because methyl bromine are on the same carbon. The methyl is on the adjacent carbon, okay? Just by rotating, you can get the same molecule. So, don't get confused that I have generated a different molecule and this is entirely different, okay? They are one are the same. Just need to observe the molecules and compare them, okay? So they are one are the same. So this is called as ring expansion. So why all this is happening? Because it is giving extra stability to the molecule, and you should practice more such examples to understand what is ring expansion, how you shift the hydrides, methyls to form a better stable carbocation. Thank you for watching this video. Until next time.